Hello friends, today I will discuss the derivation for power developed and the torque developed in a salient pole synchronous motor. In this video, the assumptions are the power loss is neglected, the power input power is equal to the output power, and the terms that are used here are stator voltage, stator current, quadrature current, direct current component of stator current, that is id iq, xd xq means direct axis reactance, xq is quadrature axis reactance. So the equivalent circuit of the salient pole synchronous motor is like this is the va applied voltage to the stator per phase, and Ia is the armature current. This is also called the stator current. Ra is the resistance of the stator per phase. Similarly, Ef is the excited voltage in stator circuit. Iq, Xq is the voltage drop which opposes the Va. Next, JID, XD, another voltage drop that opposes the applied voltage. So this further simplified like this. So applied voltage per phase is Va and the armature current is Ia and the armature resistance is Ra and the quadrature axis reactance is Xq, that is J into Xq. Then here there is another voltage drop that is nothing but J into Id into Xd minus Xq, and this is the excited voltage in the stator. Then taking all this into account, so vector diagram is to be drawn, and from that some of the relations will be calculated mathematically, and then that will be used for calculating the torque. It is like this. So to draw the vector diagram, this is the procedure. First, fix the scale to the stator voltage Va and draw that line OA which represents Va. This is the stator voltage per phase. Similarly, stator also takes the current because it is a motor. So that current we call as Ia, and this Ia lags the Va by an angle called phi like this. Now calculate the voltage drop Ia into Xq, and from A draw a line AC which represents minus J Ia Xq, but it is perpendicular to the Ia vector. This will fix the direction of the Q axis and also the direction of the EF. So from O, draw a line passing through the C, point C like this. This will represent the Q axis, and this on Q axis, this is a point. This point having known the Q axis, calculate IQ from point A, draw a perpendicular line so that it will cut the Q axis at point D, and then from point O draw a perpendicular line to the Q axis to represent D axis like this. Then calculate the IQ and ID values. One is in the D axis, the other is in the Q axis like this. And the angle between this EF and VA is nothing but delta, that is also called power angle. Whereas the power factor angle is the angle between VA and IA, which is represented by phi. Once the vector diagram is drawn, then calculate the various values. This OA represents the applied voltage per phase, and AC represents IAXQ, and AD represents IQXQ, DF represents ID into XD. Next, OF represents the EF. So taking all this into account, the vector diagram look like this. And from the vector diagram, so various relations can be obtained. That is, one is VA is assumed as reference, VA at an angle of 0, and EF will lag the VA by an angle called delta, that is represented by minus delta. EF is equal to EF at an angle of minus delta. And ID is VA cos delta minus EF divided by XD. Similarly, it is possible to calculate what is IQ, that is VA sin delta divided by XQ, and VD is equal to minus VA sin delta. Similarly, VQ is equal to VA cos delta. Once all these parameters are known, it is possible to calculate real power per phase using the formula, that is P is equal to VD ID plus VQ IQ. So VD is nothing but the direct axis component of the applied voltage VA, and similarly VQ is the quadrature component voltage, and IQ is the quadrature component of current. Similarly, ID is component direct axis component current of main current IA. So as is already observed in the vector diagram, this ID, VD, VQ, IQ are calculated. Just substitute here. In place of VD, substitute VA sin delta, and in place of ID, calculate ID, that is VA cos delta minus EF by XD. Similarly, VQ can be written as VA cos delta, and next IQ is nothing but VA sin delta by XQ. So on expanding and rearranging the terms, we get VA EF sin delta by XD plus VA square sin delta cos delta into 1 by XQ minus 1 by XD. And in the next step, VA into EF divided by XD into sin delta plus VA square sin delta cos delta into XD minus XQ divided by XD XQ. Divide and multiply with the 2, both numerator and denominator, we get like this. And as we know, 2 sin delta cos delta is nothing but sin 2 delta. So that can be further simplified like this: VA EF by XD into sin delta plus VA square into XD minus XQ divided by 2XD XQ into sin 2 delta. So next to this is the per phase real power produced or developed. To get for 3 phases, multiply these terms with 3. It is like this: 3 into VA into EF sin delta divided by XD plus Vs square xd minus xq divided by 2xd xq sine 2 delta. And it is observed that first term is similar to the round rotor uh, synchronous motor power, and PR is the power due to the saliency of the rotor. So then torque can also be calculated using the formula torque is equal to Tm by omega s, and power equation right as it is, only thing is divide with omega s. And once the power angle curves are drawn, this is the delta, this is the Pm, and it is observed that one curve 1 is belongs to the synchronous motor, and the second curve is belongs to the reluctance of the motor, and the resultant of these two curves is like this. There is a steep increase in the characteristic of the resultant power angle diagram. So it is observed that in this case the maximum torque is obtained below 90 degrees instead of at 90 degrees, because it is reaching its maximum before 90 degrees, and that too it is steep in nature. And the second curve is, that is due to saliency, the equation becomes like this: Vs square xd minus xq into sine 2 delta divided by 2xd xq. This is called the generator mode, this is called the motor mode. So from this equation we can observe that there are two torques available. One is due to the reluctance, the other is due to the its cylindrical shape rotor. So the net torque of salient pole synchronous motor is more than the net torque of wound rotor synchronous motor.